of all, I am going to introduce Mr. Amol sir. Uh, he's he's completed a master degree from the NIT Meghalaya, and he's has 2 year experience in logic gates. His project title is logic gates. Okay, and now he has completed a 2 year. He has a 2 year experience in GRF uh, from the Ljubljana University, Slovenia, Europe, and now he has as a technical engineer in. Um, am I audible? Now he is a technical engineer in Candela Technology Private Limited. So this is about the Amol sir, Mr. Amol sir. Now he is going to explain about the different kind of Wi-Fi generations. Okay, so that's all. Now Amol sir.
Okay. Thank you,
Okay.
Sham sir. Thank you, Sham sir, for the brief introduction. First of all, good afternoon, everyone. And as Sham sir told, I will briefly introduce about myself also. I'm working as a wireless LAN technical engineer at Candela Technologies. So we are working on Wi-Fi, doing the research on Wi-Fi technologies, its generation, and the protocols. So today's webinar we are going to discuss. I'll present about Wi-Fi technology, generations, and its protocol. In this presentation, the thing we are going to cover are the introduction about the Wi-Fi, what are the governing standards body of the Wi-Fi, and its history about the Wi-Fi, and the detailed protocol, the wireless LAN protocol. So and its generations. So what are the Wi-Fi 0 to 7 generations? So that we are going to look into this webinar. So as we all know, what is Wi-Fi? Everyone is using the Wi-Fi in their household. Generally, as we everyone is more concerned towards cellular network and Wi-Fi in our in every organization or in every household, we are using Wi-Fi. So what are the standards for Wi-Fi? How the Wi-Fi came into existence? So Wi-Fi is actually the research on Wi-Fi started from 1984, and the alliance, the Wi-Fi alliance, the group that is formed by FCC, the Federal Communication Department of USA, has established the IEEE standard of 802.11 standard. So uh, as we all know, the Wi-Fi works on radio signals. So different Wi-Fi card adapters are available nowadays. We have we have differences between the network, such as local area network and wired local area network. We also called it as a wired Ethernet connections, and another one is wireless LAN network. So in local area network, we are using the LAN cable, RJ45 connector, the Ethernet cables we are using for the internet connectivity from the ISP, the internet service provider, to your router or your access points. Then after the Ethernet connections, the wireless LAN network comes into the picture, where we are establishing infrastructure for wireless networks. And the standard that is used is IEEE 802.11 standard. So as we all know the full form of IEEE, I don't think it will be necessary to talk about the IEEE. So what are the IEEE standards? First we'll talk about 802 standards. So in 802 standards, we have only four standards that are very important. The first one is 802.3, that is Ethernet standard. Then we have 802.11, that is wireless LAN standard. So that's what is the focus of our webinar. And then we have the PAN network, that is personal area network, and the broadband wireless network. Apart from that, uh, in the slide you can see that there are some standards are indicated with the down arrows, so they are kind of getting outdated. So in a way they are hibernating, so such as technical advisory group or logical control or cable modem. Those are not useful at all. The most important standards are Ethernet standard and the wireless LAN standard for the communications. So what is wireless LAN, and how 802.11 is came into the picture? So wireless LAN is a high speed data transfer without wires. So that's why we call it as wireless LAN, and mostly it is RF based, and uh, we are using optical fiber for the communication between the different access points. The wireless LAN standards legacy has been established in 1991, where the FCC and the Wi-Fi Alliance Group has introduced this standard 802.11. The working group which is monitoring 802.11 are LMSC, the Landman Standard Committee. So initially in the beginning they came up with the RF based standard of 1 Mbps, and the working on actual Wi-Fi started in 1991, and the committee has established the standard in 1999, where we have 802.11 standard. This is the original standard. After that, multiple standards such as A, B, G, and AC, AX, these standards came into the picture. Here I'm giving the brief overview of what is 802.11 and what are the standards. So here we can see the detailed standards that are in 802.11. So the first one is 11A, B. You can start it from ABCD, all the alphabets to the XY. Only the Z is not came into the picture yet. So mostly the standard that we are using presently are A, B. A supports 54 Mbps standard, which is a 5 gigahertz signaling rate, and which came into the picture in 1991. Then we have the B. Actually, in the beginning, B standard came into the picture, and after that, A standard came into the picture. So that's why the B has a less data rate, that is 11 Mbps, and which works on 2.4 gigahertz. We'll talk about 2.4 gigahertz and 5 gigahertz. What is the difference between these two frequency bands, and how these frequency bands are came into the picture. So this is the B standard, and then we have the 802.11 G standard, which is 54 Mbps standard, and which is working on 2.4 gigahertz, which came into the picture in 2003. Then we have this KVR standard, like K is wireless LAN management standard, which we use it for uh, roaming purpose. As we are roaming, considering the picture of cellular network, where we are roaming from one cell to another cell, or one city to another city. So we are traveling from different regions of the tower, that we call it as tower. So actually we call it as base transceiver stations. So as we are roaming from one city to another city, the frequency band changes and our cell network changes. The same way, um, in one particular campus, suppose consider the campus of Parul University, where we have different access points. So if we are traveling from your library to your mess hall, or from one hostel to another hostel, so there the different access point will be changed. So in that case, we will be using the KVR protocols. So K is the management protocol, and then we have 802.11v, which is wireless network management protocol, and R is the fast roaming protocol, where we are using basic service set transitions. We'll talk about what is basic service set. So here we have seen, like, briefly about A standard, B standard, G standard. Then the most important standard is 11N, that most of your mobile devices or laptops are supporting with 11N standard, and which has a uh, more data rate, more than 100 plus Mbps, and which is an improvement over previous standard 802.11g. And the advantage of 802.11n standard is it is backward compatible. Suppose I am using a cell phone which supports G standard, and right now the access points are of n standards. Then and then they supports the backward compatibility as well. Then these are the a family of 802.11 protocols. So now at present we are using AC standard, which is the combination of uh, mm, uh, uh, different data rates. And in the right now the research recently in 2017, the AX standard has been launched, which is giving you 10 gbps of data rate. And uh, this is based on this one we have different generations based on the standards. So this is actually the governing body of Wi-Fi Alliance. They are monitoring the Wi-Fi spectrum. So we have two spectrums. One is 2.4 gigahertz and another one is 5 gigahertz. So these are non-licensed spectrums. So FCC has allowed this non-licensed spectrum to use as a use for Wi-Fi communications. And now we have another communication, which is another frequency band, which is 6 gigahertz as well. So we call it as Wi-Fi 6E. So that is actually the 6 extended band. So generally now, what are the founding companies for Wi-Fi Alliance Group are Nokia, Symbol Technologies, Lucent. These are quite well-known companies. Yeah, the Nokia faced some bad luck because of not running with the technologies, but uh, uh, they are in the Wi-Fi Alliance group, and they are managing what spectrum has been allocated to the Wi-Fi. And as it is a non-licensed spectrum, so different equipments uses this spectrum as well. Suppose your microwave oven, your Bluetooth devices, they also use the 2.4 gigahertz spectrum. So why we felt the necessity of using different spectrum is to avoid the interference between these household devices. So as I briefed you about the history of Wi-Fi. The research is started in 1985 on allocating different bands. So then we have the Victor Hayes and Bruce Take. Actually, these are the IEEE committee guys who established the standard of 802.3, which is a Ethernet standard. And based on that, in 1997, the committee has agreed on uh, giving the 1 Mbps data rate at 2.4 gigahertz frequency band. So this is how the first B and A standard came into the picture in 1999. So first standard came for the Wi-Fi came into the picture was 802.11b, which is operating on 2.4 gigahertz. Then we have A, which is operating on 5.8. Actually, we call it as 5 gigahertz band, but it is actually ranging from 5.1 gigahertz to 5.8 gigahertz. Then after 1999, when this Wi-Fi Alliance group formed this 802.11 standard, then actually the different manufacturers started making the devices. So Apple was the first manufacturer who uh, who manufactured their laptops and their phones, uh, laptops with Wi-Fi card. So they introduced the NIC system, that is network interface card, into their laptops. So Apple introduced the Wi-Fi to the public, and they launched the Wi-Fi commercially to the market. So as I told you, these are the major standard that are currently used. So A, B, G, N, AC, AX. So till now we have AC standard, and now the market is getting flooded with AX, APs, and routers. So if you are going to buy some router in to some shop, you can ask what standard does it supports, and how much clients it can support. Now why we are feeling the necessity of increasing the data rates, and why we are concerned about data rates. As we all know that different IoT systems are coming into the picture, our household is getting smart. Now we have the smart door lock, we have smart refrigerator, we have smart TV, our TV is operating on the Wi-Fi. Everyone is moving into the IoT devices and the system. So as number of clients are increasing, we need more serving area and more data rates. So the speed shouldn't be less, and in every household we have like 4 or 5 people, everyone is using smartphones. So for that one, they need a larger coverage area with high data rate. Everyone is using Instagram, Netflix, so they YouTube. They don't want their data to be get buffered. Their streaming shouldn't get buffered. So that's why we are feeling the necessity of uh, introducing the new standard with higher data rate and larger range. So this is actually the generation of Wi-Fi, where we named this standard as a generations. So in the first standard we launched with 802.11 standard, which is 2 mbps, and which is actually used for residential use, and it is launched in 1997. uh, and the second generation standard, which is launched in 1991, was 802.11, and which was giving the data rate of 11 mbps, and it is introduced with basic internet security, but it wasn't that much advanced and the data rate wasn't that much good. So then the Wi-Fi Alliance Group launched the third generation, which is A and G standard, which supports 54 mbps data rate, and it is Wi-Fi enterprise based, which has advanced security. And I hope you know about voice over Wi-Fi technology. The third generation standard is supporting 802.11 standard. So after that we have like the fourth generation standard, fourth generation protocols, where we are having 802.11n. So which is giving the data rate of 600 mbps, and which also supports MIMO technologies. Then which supports MIMO technology, and this is actually used for public enterprises, which is launched in 2007 and 11. Then in 2013 around, the AC standard came into the picture, which was giving the data rate of 1.7 gbps over, and which is launched with OFDM technologies. Then we have the application of AC standard was very wide range. Our cell phones were cell phone laptops, they were used with AC generations. They are launched with AC generation, the fifth generation. Now the sixth generation, we are in the sixth generation right now, where we are supported with multi-user MIMO technologies, and we are supported with 2.4 gigahertz, 5 gigahertz, and 6 gigahertz frequency band, where we are having different advantages of band steering and applications in Internet of Things. Then uh, in the future we are looking for seventh generation. At the present, the research is going sorry nah, uh, in the sixth generation we have actually the 802.11ax. Sorry, here there is some mistyping here. 802.11ax is actually the sixth standard. Which is high efficiency standard, which can be deployed in dense environment. Suppose we have different different companies, multinational companies, they have multiple uh, employees working together, so they need high speed internet. So in that case, for the dense environment, the 802.11ax standard can be used with IoT applications as well. So and this in the seventh generation we have 802.11be, so which will give you the data rate of around 10 gbps data rate, and which will be using multi-user MIMO technologies. Yeah, I know, like I can understand these concepts of what is multi-user MIMO, and what is data rate, how these things are working. So these are actually pretty complicated things at the moment, but if someone wants to study this technology in detail, it's kind of a big ocean. So uh, uh, it's a very every topic will take an hour to discuss, like MIMO or data rate, or what is the subcarrier, so frequencies that we are using. So generally, what are the pros and cons of 802.11 standard? So the best advantage of this standard is the mobility, where we are moving from one station, one point to another point. Suppose you are working in your mess hall, then suddenly you are going to your library. You can carry your laptop. Your network can your network won't break. So that is the advantage of mobility and compatibility with IP networks. So it is compatible with both IP standard, that is IPv4 and IPv6 standard. As we are running out of public IPs, that is IPv4, so it will be compatible with IPv6 address. So that will as our laptops and smartphones are coming with both the standards, this 802.11 standard is also supported with compatible with different IP standards. Then we have unlicensed frequencies, so 2.4 gigahertz, 5 gigahertz, and the FCC has recently allocated 6 gigahertz band as well. So here we will talk briefly about what is 2.4 gigahertz and 5 gigahertz band. So in 2.4 gigahertz, uh, uh, the advantage of 2.4 gigahertz is that we have total 11 channels. So out of 11 channels, 3 channels are which are non-overlapping channel, that is 1, 6 and 11 are the non-overlapping channels. So that can be used for your frequency, your data rate transfer. And each channel is divided into different bandwidth. Suppose now we have 20 megahertz bandwidth channel, 40 megahertz bandwidth channel, 20, 40, then we have 80 megahertz. Now the AX system are coming with 160 megahertz channels. Then we have the Wi-Fi 7, which is BE standard, which will come with 360 megahertz bandwidth. What is the advantage of having this different bandwidth is uh, uh, giving access to the multiple clients. So that is the advantage of having multiple channels and multiple frequencies and different bandwidths. So in 5 gigahertz band we have around 36 channel, and in 6 gigahertz that number of channels are extended to 233 channels. So as we have more number of channels, it is possible to serve multiple clients together. Then we have easy and fast installation. The advantage of Wi-Fi is easy and fast installation. It just take half an hour to install a router. And nowadays it is getting more cheaper. It is scalable, and it is very simple to understand. You just have to connect with your SSID, or we call it as in a layman term we call it as the Wi-Fi name. So suppose you have a parul hotspot, like Wi-Fi hotspot, we call it as Wi-Fi hotspot, but the technically we call it as SSID, that is service set identifier. So these are generally the pros of 802.11. There are very few advantages such as multipath effect in indoor, so that's why we are going for different frequency bands. And the interference is uh, quite a haunting parameter for the Wi-Fi technology. So we have the co-channel interference, like in 2.4 gigahertz we have the interference with our microwave oven or Bluetooth devices. So they are mostly interfering with our Wi-Fi streaming. So if you can if you are close to an microwave oven or any washing machine which is operated on Bluetooth technology, if you are close to that equipments, you can see that there is some lag in your video buffering at YouTube or Netflix. And another is a power control. Yes, the power control is kind of a major issue that now all the Wi-Fi technologies are facing. As we have seen that all the most of the routers and access points are coming with power. So whenever there is a power cut, we can't use the Wi-Fi. As this is the advantage in cellular network, where we don't need a power at your household. If your phone is charged, then you can use it for a longer time in emergency purpose. So that's why the Wi-Fi routers are coming with mm, uh, uh, power inline Ethernet switch. So uh, uh, instead of giving the power from your house, they are coming with inbuilt power that is coming through the LAN cable. So these are generally the pros and cons of 802.11. So what is the how infrastructure works for 802.11? As you all most of you all are computer science student, you must have studied little bit of computer networks. So we have this so-called OSI layer and the OSI model and the TCP model. So here, in which we have the physical layer and the MAC layer. The bottom one is the physical layer, and another one is the data link layer. We call it as the MAC layer. So generally, the Wi-Fi 802.11 protocol is communicating only in these two standards, uh, in only these two layers, that is MAC layer and the physical layer. In the application layer, like uh, if we are using some internet protocols, then the remaining layer will come in picture. So here in this infrastructure, you can see that we have a client, that is either it can be a laptop or cellular devices or any other IoT devices are connected wirelessly to the access point, and those access points, or we generally call them as a router, are connected to some server or ISPs, internet service providers network, via wired network. So now we will see each protocol in detail, very briefly. So the first standard, which is 802.11a, which has a 5 gigahertz band and which is using the OFDM technology, which is and it has a multi-carrier modulations, and it is varied with different data rates, maximum supported up to 54 mbps, but depending on the application, the data rate can vary from 6 to 54 mbps. And we have different sub carriers. So our frequency band of 5 gigahertz is divided into different sub carriers, which supports the modulation technique of BPSK, QPSK. You might have heard about these communication terminologies. And we have these 64 quadrature amplitude modulation schemes, and the spacing is 0.3 megahertz. So as we move on to the higher protocols and the higher standards, you can see the difference between the modulation schemes and data rates based on the and there will be the improvement in the sub carrier frequencies as well. So this is the overview about the 11a standard, which is not used nowadays, but our present devices are compatible with 11a standard also. So the first standard actually for a Wi-Fi Alliance kept was 802.11b, which supports a direct spread sequence modulation schemes, and which has a data rate of 11 mbps. The reason is, as this was the first standard and which was launched with 2.4 gigahertz frequency band, it was supported with uh, less data rate. And uh, 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 the advantage of this protocol was the maximum throughput and maximum coverage rate with less data rate. So it was giving the maximum range. The advantage of 2.4 gigahertz frequency band, the reason why we are using 2.4 gigahertz band is it has a larger coverage area. So if we have a larger enterprise network, where consider the campus of Parul, where you have some hostel, and the management is providing only one router, then the management will provide a 2.4 gigahertz band, and yeah, and the students will complain about we are getting the less speed. That's the reason that you are allocated with 2.4 gigahertz. So if someone allocates you 5 gigahertz band, then the range will be less but the data rate will be high. So and you will have the continuous streaming. So that is the difference between the frequency bands, and the brief overview of 11b standard. Then we have the next standard, that is 11g standard, so which was released in 2.3 and which also operates on 2.4, but here we have the maximum data rate of 54 mbps. As in case of B, we had the data rate of 11 mbps in 2.4 gigahertz. So in that duration, in that time frame of era of 2003, there was a need of a larger area and less data rate, as there were not any smart devices which were using the internet that much. So that's why it was sufficient in that time zone that they have the maximum data rate of 54 mbps with 2.4 gigahertz. Then the cell phone the smartphone has been launched, and the Wi-Fi Alliance group launched the 11N standard in 2009, which has a MIMO supports. That is, we call it as a multi-user, multi-input, multi-output antennas. So uh, then it was supporting up to 600 mbps data rates, and which was operating at the frequency of 2.4 gigahertz. In the operation of 2.4 gigahertz was more compared to the 5 gigahertz, because it wasn't that much necessary at that time of the 5 gigahertz bands. Then uh, that time we felt the necessity of higher data rates with uh, even though the coverage was less. Then they came up with a AC standard, uh, which has a wider channels of 80 and 160 megahertz. If you think about N standard, the 802.11 N standard supports the bands are 20 megahertz and 40 megahertz bands, and here in the AC standards we have 80 megahertz, 160 megahertz bands. So it was possible to connect multiple clients together. uh, I mean, in multiple clients in the sense, we can connect multiple smart devices, the laptop and the cell phones, together to the router. So it was allocating more users. Then it was supporting the data rate up to 1.3 gbps, or no, 1300 mbps. And this was the first standard which launched actually the multi-user MIMO technology, which was increasing the number of it was supporting the multiple clients with the help of multi-user MIMO technologies. So the number of client support increased in the AC standard. So this is how the performance of AC standard has been improved day by day. So here in the first generation, the data rate was like 2 mbps, then 11, then 54, then 600. And with the fifth generation, that is AC standard, which has gigabits of speed. So today, uh, uh, till today, we are using, most of our devices comes with AC standards. Not most of, like 80%, 90% devices at present in the market are supported with AC standards. So uh, here we'll go through the brief difference about uh, N and AC standards. So as I told you, the N standard supports with 20 and 40 megahertz, and AC standards is 80, 160 megahertz. Here the most important factor is the modulation schemes. So here uh, N standard supports up to 64 QAM standard, whereas AC standard supports 256 QAM. So the advantage of 256 QAM was the security. It was providing more security in the 8 bit encryptions. So 256 is 2 to the power 8. So we were providing 8-bit encryption security measures. So the AC standard actually provided more security with more data rates, and it was supporting the Mac enhancement at uh, with extension to high data rates. So this is generally the difference between N and AC standards. So but the AC access points were still backward compatible with N standard. So yeah, this is actually decides how we are going to uh, decide the data rate and which modulation index will be which modulation will be used. So this MCS table is very important for the Wi-Fi people. So we call it as MCS index table, so which is modulation and coding scheme index value. So as we are having modulation up to uh, uh, 256 QAM, but with uh, uh, the 256 QAM was supported for AC standard. Then we have AX standard, which is supporting 102 QAM. And as we are going for Wi-Fi 6 in the future in 2023, with Wi-Fi 7 generation, the QAM will be increased up to 4096 modulations. So this is a very advanced topic of modulation scheme, so I'll just skip it for now. So here we can see the speed comparison between different standard with different frequency bands. So here, as if we are using 20 megahertz bandwidth, then you can see how the data rate has been improved from B standard to the AC standard, where we have 11 mbps to up to 693 mbps. And here the 802.11 AC standard is supporting 8 special streams. So 8 SS is actually the special streams. Then we have up to in if we move to 160 megahertz bandwidth, then you can see the data rate has been drastically improved from 693 mbps to 6.9 gbps. So this table will uh, n- clear the difference between the data rate for different protocols with different bandwidths. Yeah, now we are at the standard of AX 802.11 AX standard. So here uh, uh, the AX standard, all most of the smart devices, the laptops and the smartphones are coming with AX supporting. And this AX standard is compatible with N and AC standard as well. So if you buy some router or access point, you can see that in the features you will see which standard it is supported, which protocol it is supported. So if it is supporting AX standard, of course you should go for the AX, that router or that access point, because it has uh, huge number of tremendous amount of advantages compared to the AC access points. So in the AX standard, the first thing, the important thing is the capacity. So the AX is improvising with the data rates and supporting multi-user MIMO. So here, uh, in the traditional approach, we were just using few devices which will be accessed with the by your access point. But with AX standard, we are trying to increase the capacity. So what is meant by increasing the capacity is we are increasing the number of clients. So as we are having multiple mobile devices or IoT devices, we are demanding more connections to the router. So this AX standard is supporting multiple clients. So that's how it is increasing the capacity in the dense environment everywhere. IoT devices are getting launched every day. Millions of devices are accessing the billions of devices are accessing the internet. So that's why it was the necessity of launching the AX standard. So yeah, as I told you about AX, it is designed for high density connectivity. So consider a company where there are thousands of employees. So all they have their tab, they have their smartphone, they have a laptop, and they need the internet connectivity for all the devices. They have their smartwatch. So they need the internet connectivity for that accessories. So we are making the access point and the router as a smart devices. So they are able to handle multiple devices, and which can handle the resource scheduling. So the scheduling algorithm is kind of complicated, where we are giving the limited amount of time for particular device. It is generally, we call it as a lease time. We are leasing particular IP to some devices, and for a particular time frame, then we will take out the lease of that device if that device is not in the network. So this is the high density. So what are the building blocks of 11ax standards? Are the first one is 8 cross 8 multi-user MIMO, where we it is supported with uh, 8 special streams with downlink and uplink, which has which is launched with OFDMA technology. So as we have seen that till 11 N standard, we were having OFDM technology, which is orthogonal frequency division multiplexing. And here we have the OFDMA technology, which is orthogonal frequency division multiple access technology. So the difference between these two technologies are, we are dividing the bandwidth of the channel up to 5 megahertz. So as the AX access points are supported with 160 megahertz, and we are dividing those channels, that bandwidth, into 5 gigahertz. So we are trying to connect more number of devices. So uh, and the next advantage is 1024 QAM, which is the modulation scheme, and which is of a 10-bit modulation scheme, and that is actually used for uh, uh, which is providing the more security. And then we have the Bss coloring. Yeah, this is actually very interesting phenomena of Bss coloring. Bss actually stand for basic service set, in which we are for one access point we are giving some color coding kind of a scheme, and the area of a particular router or particular access point, we call it as a Bss. So this is the uh, and we are giving different color coding scheme to the different access point. So it is quite easy to do the handoff between one access point to the another access point. The handoff generally means we are moving from one access point area to another access point area. That's how Bss coloring is very important. Then we have the advantages of band steering. So as we know, the 5 gigahertz is having the uh, 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 more data rate. So our as the routers are becoming smarts, the routers are controlling the more frequency bands towards 5 gigahertz. So it will always try to give me the 5 gigahertz band. So then we have the multi-user MIMO technology. As I told you about the multi-user MIMO technology. So these are the complementary. In this slide you can see the very simplified view of OFDMA and MIMO technology. Mm, so here in the multi-user MIMO technology, you can see that rather than uh, carrying deliveries such as one truck, someone wants to use send some tables, they will use another truck, and someone wants to send some computers, they will use another truck. So generally the OFDMA technology, in the OFDMA technology, we will send the truck, the computers, the table, and the chair in only one truck. So that is how the OFDMA technology is advantageous about in the Wi-Fi domain. And the next thing is uplink and downlink. In OFDMA, it is actually the contention based. So if you can see here on the picture on the left side, there is a lot of contention, a lot of traffic jam, you can say. So there it's not a proper controlled way. So in the AX way, in the AX standard, we have proper scheduling algorithms, where we are managing the traffic, incoming and outgoing traffic, uh, for the access points. So these are generally the scheduling algorithm for AX standard. So and as I discussed about 1024 com as well. So here, in o- o- in AX standard, we have the long OFDMA symbol. So this was all about the brief overview of uh, Wi-Fi generations and the standards. So I'm opening the webinar for the questions. So if you have any questions, please go for it. Thank you. Hello.
Yes, sir. Yes, sir.
Yeah.
Yeah, I think no doubt from anyone.
Okay. Thank you, Sham sir, for this opportunity to
Okay,
discuss about this Wi-Fi technologies.
thank you, Amol, sir. Okay,
Okay.
so I hope. Thank you, Amol sir. Okay, for
Okay.
giving the brief introduction about the Wi-Fi, and
Mm-hmm.
thank you for the giving for the view webinar. Thank you, and I hope it will be helpful for our student as well, our faculty member. Thank you, Amol sir.
Okay. Thank you.
Sir,
Yeah, I'm just connecting it, disconnecting.
okay, okay. Just wait up. I'm waiting for the